Josh already talked about my presentation, Josh, but Josh, I'll tell you that the help is on the way. I got some DNAs on the way to you very soon. So you haven't heard my talk. I think it's we started talking about this 2 years ago, but this year really we make some progress with people's help, and I named this. I think we got it because of this beautiful, Josh and Valia talk about, and the high resolution map and the physical map. And really, Josh already mentioned this. He did not share with me. I'm just make a claim here. And I think finally we got this gene. I call it Locus the gene, called the peanut spotted wilt disease resistant gene 1-1, because I believe there's another gene on chromosome B9. This one on chromosome B1, chromosome A1. Knows that we, doing this kind of research, just like Julia just mentioned, that genetic material is so important. So my group developed this population, long time ago, started 2005. And through those years, the first one, we used the EST-SSR. So we had this genetic material, but we do not have molecular tool. And through those years, we can see we started to use SSR marker, and then since the genome sequencing was done 2016, and for the diploid and for the tetraploid 2019. So we developed this SNP array by the community. So version 1, then Josh improved this with version 2. And with this cost going down, I think finally I genotyped the whole population 350. Instead, in the past, we used part of this population, like 140, and for last couple of papers. And this one is a summary. And for TSWV research involved the NC94022, there are two populations. One's in Tifton, this is SunOleic 97R crossed to NC94022, and another population developed in Florida and published also. There are two papers published. As you can see here, that's a summary. In Tifton group, our QTL, we have 3 papers. You can see there. Really, it's the QTL focused on that 10 million base on chromosome A01. And the 2 papers, the QTL by Florida, they more kind of focus on in the middle of the chromosome A01. But you can see there is a big major QTL on chromosome A01. That's the message we got through those years. And this slide just to share with you that what we done use this real population as real population. And we phenotyped this population from 2010, 2011, 2012, 13, 14, 15, actually also 16, then 2019 to 2020. And this morning you can see Albert Colbert's presentation that 2019 to 2020 really are 2 big years for TSWV. And for this population, well, first Josh used that whole genome resequence data. We resequenced 145, we identified the QTL on the chromosome A1. And also we used the version 1 SNP array. We genotyped 145, the same lines did the whole genome resequence. And those data are published. Finally, again, we used the improved SNP array version 2. We genotyped the whole thing, 350. That really is a game changer. This distribution is on this, and primarily we used 2013, 2019, and 2020, those 3 years phenotype data. Here, this table just showing you that version 1, we did genotype 145, And this is the map. And the map distance is 3,300 in the centimorgan with a total about 1,000 loci markers on the map. So really still not high enough. And that's the QTL we identified for this used version 1 genotype 145. There's a 1 QTL with 41%. And on chromosome 1, add about a 10 million base physical map position. That's where is this physical map at a 10 million base. And this also you can see here is that a graph published like Josh shared, that bin map, and use the resequence data 145 lines. We identified this 36, QTL with 36.5%. And this, I said, this will version 2 just wonderfully, beautifully improved by Josh Clevenger. And as you can see here, we genotype the 350, the whole population. And what I want you to see here, just see the SNPs, the distribution in the whole genome. As for the chromosome A01, see how many markers here on the chromosome A01. It's just beautiful. And this table just summarizes this genetic map, use the version 2, genotype 350 again. And you can see the whole map length is similar. It's a 3,000 centimorgan, but the marker on this map is 3 times higher, 3,000, 3,100. I want to point out here, you can see A01. On A01 chromosome A01, there are 367 polymorphic stem markers on that chromosome. And this slide just summarizes the QTLs through those years by using this version 2 and the genotyped 350 lines, real lines. And you can see here, this chromosome 1 is always pop up. And with the QTL here, with the contribution to 22% to 43.7%. So it's a 44%. And for this, using this version 2. Surely there's a major QTL. What I want you to put here together in version 1 here on left and the version 2 on the right. In the middle, that's a physical map. As you can see here, we put all those together. It's a stem marker. It's a used diploid physical map position. So we convert that one to the middle, the physical map, and the tip runner. So that's a tetraploid. As you can hear, you see here, this for the version 1 is a QTL with 490 kilobase, and the version 2 with a 44%. That's in this region. In this region, there are three major genes, resistant genes. One is this one, NBS-LRR R-gene, another one MLO gene, and then there's another one. It's also another gene. Next slide, I'm going to show you. But I want to point out here is that why this, it's just why this one is better than the one we published. The one we published by Garaf in that bin map, really we cannot separate this section, no recombination. We couldn't see any recombination breakup here. So that's why he focused on the catenase genes. So we didn't see this NBS gene. But this SNP array, we can see this gene. So next slide, I did the genotype to really see the whole 350. I did this myself. And this slide really give you two messages. One, you take home two messages. Here you can see in the middle, that's a 1 million base pair. This big 1 million base pair set block. There's no segregation. No segregation. I call it cold spot. But luckily enough, I finally saw two lines RIL S1 and S17. Out of 350 RIL lines, only 2 lines, S1 and S17, break up here at this point. This breakup point is between this catenase, you can see here, this catenase, and this NBS-LRR R-gene. They break up. So this S1 is very susceptible through those years. And S17 is very resistant through those years, every year. So I really think, I believe, and finally, I think this is the gene we are looking for last 10 years. And this slide is Josh provided me this slide. So I told Josh, I said, Josh, I want to buy the sequence to prove this is a breakpoint. So he did. So Josh mentioned, really made a comment. He said, probably with the divine power, and that's the gift he gave to me. So you can see this break up S1, S17, break up this SNP at this 12 million base pair. That's the exactly, you can see here, it's a 12.04. That's 12 million 04 at data point. So that's approved by the sequence that's here is the breakup between S1 and S17. So we then, because we have this reference genome, that's the beauty. We have the reference genome. You can see here at this region, you see the gene name and the position of physical map. That's at a 12 million base pair region. There are 3 genes. One is the NBS gene. That's the one. I think that's the gene for the TSWV resistance. That's another gene, glutamate receptor. That's at 12.37. That's another one, MLO-like protein, like gene. That's at 12.41. So really, this section, there are 3 genes. I think related to this resistance, but I think is this one, NBS-LRR gene. The reason why is that, so we did this morning. Also, you heard this tomato resistant gene SW5. Okay, we did this comparison of this gene at the chromosome A1, and also 3 other NBS gene at the end of this chromosome. That's let me show you. That's at here. This another 3 NBS gene. You can see here they contributing a little bit somewhere, but it's not this NBS gene. It's this NBS gene.
2 minutes, Baozhu.
Okay, so we compare those 3 NBS gene and this 12 million base pair NBS gene and this gene. Those 3 genes much different from this SW5. So, and with that said, and this morning you also heard that talk about the SW5. I think that's the SW5. They cloned this gene, then put this gene into tobacco, showing that resistance to TSWV. So what are we planning to do next? We planning to do next for the PSWD-1 peanut spotted wilt disease resistant gene is going to do the same, and to clone this gene, put this gene into tobacco. So I like to take this opportunity to introduce you a new PhD student, Ethan Thompson. I think he's watching also that that's part of his PhD work, to clone this gene and put this gene into tobacco to characterize this functionally, this gene. Also, I like to introduce you to pay attention to a poster led by Fontaine. That's we think we are also identified a gene, a locus on chromosome A02 resistant to late leaf spot by using this NAM population approach. Thank you very much. That's it.